Welcome to the 6.2 notes on the natural base E. Our first slide here is going to be a warm-up slide, so you need to determine if the model is going to be exponential growth or exponential decay, and then identify the initial amount and the percent increase or decrease. So just to give you a reminder of what we did yesterday in class, this is going to look like you're going to look at the base. So here my base is 1.2. So because that base is bigger than 1, we're going to call this growth. And so it is going to be exponential growth. And the initial amount is what's in front of the base. So the initial amount in this case is going to be 1 because there isn't a number there. And the percent increase is going to be 20% because it is 0.2 more than 1, so it gives us 20%. All right, so question number 2, growth or decay? Hopefully you said decay because the base, 0.78, is less than 1. Okay, the initial amount. Again, the initial amount is the amount that's in front of the base, and that's going to be 1. And the percent increase or decrease, well, because this is under 1, how much under 1 is it? So 1 minus 0.78 will give us 0.26. So this is a 26% decrease. All right, so please try it then for questions 3, 4, 5, and 6. You should have decay because your base is less than 1. Your initial amount is 1 again because that's the number that's in front of the base. And this is going to be a 3/8 decay. And so if you happen to have a calculator handy, 3 divided by 8 is going to give us a 37.5% decrease. Okay, question number 4. Here's our base of 1.03. Because it's bigger than 1, this is going to be growth. Our initial amount in this case is the number that's in front of the base. So our initial amount is going to be 28. And this is a 3% increase. Okay, number 5. Here's the base. That is less than 1, so that means it's going to be decay. The initial amount is going to be the number that's in front of the base, which will be 25,000. And how much smaller is that than 1? So this will be 1 minus 0.95 will give us 0.05, which is a 5% decrease. And then on question number 6, our base is 2. So this is going to be growth. The initial amount is going to be 1 because that's the number in front of the base. And that really is supposed to say initial. And how much more is this? This is going to be 100% increase. Why 100% increase? Because 2 minus 1 gives us 1, and 1 as a decimal, or as a percentage, is 100%. Right, so there's the first warm-up. Our second warm-up is to find the inverse of a function. So remember, to find the inverse of a function, you first had to switch the x's and y's. So this is going to say x equals 1/2 x minus 1/2 y minus 5. And now you solve for y. So we're going to add 5. And we are going to multiply by 2 to get rid of the 1/2. So we'll have 2x plus 10 equals y, and that is our inverse function. Question number 2, again, switch your x's and y's. So x equals negative 3y plus 7. We're going to subtract the 7, and then we're going to divide by negative 3. So you will have x minus 7 all over negative 3 equals y. Or you could write it as negative 1/3 x plus 7/3 equals y. Either of those two equations would be correct. Number 3, again, first switch your x's and y's. So x equals y minus 9 over 5, divided by 5 specifically. So we're going to multiply both sides by 5, so we will have 5x equals y minus 9, and we're going to add 9, so we will have 5x plus 9 equals y, and that is our inverse. Okay, with question number 4, in class we talked about we have to get rid of this exponent. So how is it that we undid something that was cubed? And then we talked about that we have to take the cube root. So we want to take the cube root of x equals y plus 2. And the last step is to undo a plus 2. So we will have the cube root of x minus 2 equals y. And please be very careful that that minus 2 is not on the inside of that cube root. Okay, question number 5. Again, switch our x's and y's. And how do we undo something divided by 2? We're going to multiply both sides by 2. So we will have 2x equals y cubed minus 6. So to undo a minus, we're going to add. So we'll have 2x plus 6 equals y cubed. And to undo something cubed, we're going to take the cube root. So we'll have the cube root of 2x plus 6 equals y. And this is our inverse function for question number 5. And for question number 6, if you remember, this is just telling you that it's the domain and that we want our positive numbers only. So we'll have y, oops, not y equals, we're going to have x equals negative 2y squared. We're going to divide both sides by negative 2. So we'll have x over negative 2 equals y squared. And then we're going to take the square root of both sides. So we'll have plus or minus the square root of x divided by negative 2 equals y. And remember, we wanted the positive onlys, so our inverse function is actually going to be the positive version of x, the square root of x divided by negative 2. So that's from our first week back from winter break. Those were our two kind of things that we've done so far in terms of reviewing. So what is it that we're going to be talking about today? Well, our essential question today is, what is the natural base E? And I know you're like, E? What is E? E is a number. Besides being a letter, which can be used as a variable in math, we have discovered a number that's called E. And it's a number that happens naturally. It's approximately 2.71. Just like we have pi is approximately 3.14. E is approximately 2.71. So what are some properties about E? The natural base E is irrational. It's going to be like pi. It's a never-ending, never-repeating decimal. And it follows that it comes from, as x gets larger and larger and larger, from taking 1 plus 1 over x to the x power, it gets closer and closer to this decimal approximation every single time. So we just happen to call it E. Okay, even though E is a number, it still will hold true with the same exponential properties. So if we have e to the third times e to the sixth, how many e's do we have altogether? And I'm hoping you're saying e to the 9th. If we simplify this fraction here, we have 16 over 4. That's going to be 4. And where do we have more e's, top or bottom? Well, we have one more e in the top than we do in the bottom. So this will just simplify to 4e. And on c, this squared means it's going to be 3e to the negative 4x times 3e to the negative 4x. Now we reviewed that negative exponents cause us to have a fraction, so this is really going to be 3 over e to the 4x times 3 over e to the 4x. And I hope you remember that the 3 stays in the numerator because the 3 does not have a negative exponent. So when we multiply fractions, we multiply straight across. 3 times 3 is 9. And e to the 4x times e to the 4x will be e to the 8x because we're going to add the exponents of 4x and 4x to give us 8x. So number 6, on slide 6, we have questions 1, 2, and 3. Pause this video and see if you can do these 3 equations or simplifications on your own. Number 1 should be e to the 11th. Whoops, my battery is running low. Number 2 should be 3e to the 3rd. And number 3, we're going to have 10 over 3 to the, or e to the 3x times 10, e to the 3x times 10, e to the 3x. So 10 times 10 times 10 will give us 1,000. E to the 3x times e to the 3x times e to the 3x would be e to the 9x, again because we're adding 3x plus 3x plus 3x.